Hello everyone, my name is Sachivangar Dinesh Kumar. I'm doing Masters in Cloud Computing. So I'm doing, as part of my second semester, we have a subject called Fog and Edge Computing. So in that Fog and Edge Computing, as for the uh, continuous assessment, we are doing a project on crop analysis using the Fog and Edge Computing. So behind the reason of the project is like an by reading this research paper, by using the wireless sensor networks and IoT Internet of Things and for computing, we can give the best quality of the product, and also we can improve the production. We can improve the production of the agriculture. So this is the main idea of my I took the idea from this paper. So let's coming to the I'll give you a quick review of my project. So then after that, let's jump into the coding and I will explain you the coding. So motivation of my building the project is like, as the population is increasing, we need to improve the food production, and we need to reach the food production, and the food has to be reached to every person. So it is not happening. So because of few climatic changes and everything, we are unable to get the exact we are unable to achieve the production. As the technology improving, why don't we use this for in the agriculture system, and why don't we improve the agriculture system? That is what my idea of concept is like. This is the configuration which I use for designing my project. So RAM is 8 GB, Windows 11 operating system, the processor, and I use it the Java runtime latest environment. It is 1.8 in the Eclipse IDE. The code is written in the Java programming language. So that is the reason I use the Java runtime environment. So these are the sensor I used in my project, like soil moisture sensor. It's above it will test the moisture of the soil. So based on the values, we can turn on the motors and everything. Electrochemical sensor, this sensor is used to calculate the pH value, phosphorus, copper, and all these nutrients which are existed in the soil. So this sensor is helpful to calculate all these values. So based on that, the farmer can able to uh, buy the correct pesticides and then distributes to the exact crops and where it is lacking, where area exactly lacking of temperature sensor. So few fruits need some quality of temperature. So for that we need to be maintained. And water motor, if these values are based on these values, if the moisture is less or the chemical are sensor, so based on these everything, pH value is less, the motors will turn on and the water is supplied to all the irrigation part. So this is the topology I implemented. So I designed this topology by taking the two areas into the consideration. So in this, there are three sensors, and this is the motor, and cloud is the data center, which comes under hierarchy level 0. Sorry, it is the highest data center, and proxy server and Faulkner. SEM stands for soil moisture, EC stands for electrochemical sensor, temp stands for temperature sensor, and motor. It helps to supply the water to all the parts of the irrigation. So by taking the few considerations and few case scenarios, we understood that in the cost of execution, fog computing is taking the less cost of execution rather than the cloud computing. In the energy consumption also, the fog is less energy is consumed rather than the cloud, because these cloud data centers are placed far away from the user, so energy consumption is high, bandwidth is high. So that is the reason. In If you take network usage is somewhat bit very little value, very less than the cloud, very less than the cloud. Fog is the best in the network usage as well. For cloud is using the more network usage rather than the fog. Let's coming to the coding part. This is the coding part I used. This is the topology I created in the iFogSim. So as per the coming to the coding, so these are the number of areas where I created. So number of areas is equal to 2. So here number of areas is equal to 2. Then number of sensors is equal to 3. So here the sensors is 3 and the motors equal to 1. If you want to run this on the cloud, we need to make into the true. If you want to run it on the fog, we need to make into the false. If you set true, And if you run this application, so total network energy consumption is total network usage, and cost of execution is very less, is very high, sorry, because it is running on the cloud. So when you make into the false, so that means you are sending data into the fog node, and the computational power and the computation happening on the fog node. So that is the reason it will take the less consumption power and everything. See, comparing to the cost of execution into the cloud, fog is taking less energy consumption, less energy is consumed, and total network use is also very less comparing to the fog. So in this, I created a few modules, like 3 modules. These are like soil moisture sensor, electrochemical sensor, and so temperature sensor. So these are the nodes how I created. This is the creation of the cloud and the name, and this is the RAM, 40,000 RAM, and uplink bandwidth and downlink bandwidth, and it is the proxy and proxy server RAM, 4,000 RAM, and uplink and downlink bandwidth, and the sorry, this is the proxy server, and this is the fog node, and this is the fog node is also 4,000 RAM and 10,000 uplink and 10,000 bandwidth, and this is comes under hierarchy level 0, comes under hierarchy level 1, and fog node comes under hierarchy level 2, and sensors comes under hierarchy level 3. Here are the sensors I created. So coming to the module, how they are happening, this is the application app module, where each sensor and each thing is interacting with each other, and we are generating the values. So coming, this is the topology, main topology I implemented for smart agriculture, as you have seen in my PPT before. So these soil moisture, electrochemical, and temperature sensors, these 3 sensors send the values to the fog node, and the fog node will take the few computational power. After doing the real time computation power, it sends the response to the motor, if it is to turn it on or off. So these data is stored in the cloud data center, because in the further if we want to use for future purposes. So this is the project I made, and thank you for giving this opportunity.